Hi everybody, this is Mrs. Ellsworth, and what we're going to be talking about now is Chapter 7, which is about expressions. And our first lesson in Chapter 7 discusses the distributive property. Let's look at it. Okay, first of all, let's talk about some equivalent expressions. Here's one in this top line right here. Anyway, so we could go and add this together. 6x's plus 4x's, that would equal 10x's, right? Okay, that's cool. We could do another equivalent expression because this has the same value. We could do another one. We could do 9x plus 1x. That's equivalent to this, isn't it? We could even do 10 times x. Well, heck, that's even really the same saying right there. But these are all equivalent expressions of this one. Okay, let's look at another one. We've got 4r. So 14r, excuse me. We could do 7r plus 7r. That's equivalent to it, isn't it? This equals still 14r. It's just another way of writing the expression. Okay, we could also go and take and do 3r plus 11r. Or we could do like this one right here too. Another equivalent expression be, we could do r times 14. So these all have the same exact value as this one. And that means it's an equivalent expression. Okay, for time's sakes, we're going to move on here, but just recognize that we're going to be working with equivalent expressions with the distributive property too. Okay, let's go ahead and move on to the distributive property. So our book shows us this nice little diagram here. And it's telling you that when you have a number that's multiplied to a group, you can actually break it apart. You can take a times b, which looks like this, ab plus, and then the a times c. And there we go. So you can also do this if it was a negative in here, if that right there was a minus sign. Okay, and that works too. A makes an ab right there. And then we're going to subtract this one, and then a times c will equal a times c, or ac. Let's look at it with numbers. So you take 5 times 6. There it is. 5 times 6. Okay. Then you take 5 times 7. 5 times 7. Put the same sign in behind there. Look at this. We could also put the 8 instead of in front of it. We could put it behind it because of the commutative property. You know, when you multiply two things, even though it's a group, is a thing, and here's another thing. It doesn't matter whether it's on the front or the back. But let's go ahead and look at it. We got 9 times 8. There it is. We got, well, minus, and then 3 times 8. There you go. You could go and write that in front of it and then do it just like we did with the other ones. Okay, so let's look at an example one here. We've got 5 times 12, and we'll write it out like that. 5 times 12. And then 5 times 4. That's a 5 there. And we got that plus in between them. Okay, so we can go and multiply this out. So that'd be 60 plus, and then 20. 5 times 4 is 20, and we get 80. Now, you might be wondering, well, why are we doing all that work? I could just go and set up 5 times 16. By doing the order of operations right here. And yes, that does work too. I don't know off the top of my head that is 80. Well, actually it is. But the whole thing is that we can use a distributive property when it works better. But we're going to use this now with nice simple numbers to where we get this and understand it, and then we can move forward with more difficult concepts. Okay, we've got 4 times the quantity of 6 times 3. So if you need to put that 4 in front of there for you to be successful, go ahead and rewrite it like that. But I'm going to just go ahead and do 4 times 6 plus 4 times 3. Look at this. We could also put the second numbers in parentheses because that means you're just multiplying those. And do you see the 6 plus 3? It's a little bit easier to see. Just kind of a neat way to look at it. But anyways, 4 times 6 is 24 plus, and then 4 times 3 is 12. So you get 36. I mean, when I look at this one initially, I think, well, gee, 9 times 4, 6 plus 3 is 9, plus 4 times 4, that's going to be 36. So yeah, it looks like that the distributive property makes it more work for this one. But again, like I said before, we're going to use the nice numbers that we can do things in our head, and then that will make it clear that we're doing it right. It is very important to me that when you are doing this work that you show this step right here. That step will be graded. So watch out and make sure that you show that work in all of your work. Okay, let's look at one more on this page. We've got 3/4 times 9. Okay, 3/4 times, oops, 3/4 times 9. And I'm going to put 9 over 1 because you know how that's how you do fractions straight across there. Okay, and then we got minus. Okay, and then we've got 3/4 times 2. And I'm going to put a 2 over 1. Okay, and I'm cleaning it up. We multiply across the top. We get 27. Multiply across the bottom. We get 4 minus. And then we'll do this 3/4 times 2 now. 3 times 2 is 6. And 4. Okay, so, oops. I'm going to go ahead and subtract it. I get 21 over 4. See, 4 goes in there into 25 times. So it's 5 1/4. Okay, so that's an equivalent expression to that. Maybe you know 3/4 times 7 or whatever, and by doing the order of operations, but you would get 5 1/4. But the whole thing is that it's very important for me to have you show this step right here. I'll be asking to see those. Okay. Okay. Now this is where it changes a little bit. You get 4 times x. Okay, there's a variable. We can't do too much to go and reduce that and make it more simplified than that. 4 times 5, we can of course do that too. So let's go ahead and do that. We'll do, oops, let me get the right marker. Okay, we've got 4 times x plus 4 times 5. Okay. So we can clean this. Now, notice that this plus kind of separates these two things. So that's why I always talk about one side and the other side. This is all multiplications here. So we'll go ahead and clean that up. It's just 4x plus, and then we've got the 4 times 5, which is 20. And that is beautiful right there. You remember I said that this kind of separates the two? That's because when you do the order of operations, you must do multiplication first. And so that's why. So look at this thing. This is as simplified as it gets. There's nothing that you can do about that x because we don't know what its value is, so we can't evaluate it. Okay, so I'd like you to pause the video, have your teacher pause the video, and I'd like you to do this one, where it's 6 times the quantity of y plus 10. So go ahead and pause. Okay, we will go and take 6 times y plus 6 times 10. And I'm just writing it a different way. You'll have to figure out what you prefer. Okay, and I kind of like this because, hey, I can see y and 10, y plus 10, and that was inside of there, so I can kind of double check and make sure that I'm doing them right. What's outside the parentheses of this group right here would be 6 and 6, so I can kind of see like, hey, I got this set up perfect. 6 times y, there's nothing better to do than just 6y. That's as simplified as it gets, and 6 times 10 is 60. So now you can kind of also see why I wanted you to do with this numbers on the first example. Yeah, because numbers we're fine with. It's just when we start putting variables in there, we can kind of let it bother us. Well, what does that variable equal? It doesn't matter in expression. Okay, there's an equivalent expression. That's really what we're going for right now. Your book has got this diagram here, and I'm going to skip that because of time. We're going to move forward here. Okay, I would like you to pause the video and wait, we'll go ahead and do this one here together first. Okay, we've got 2.4 times a. Okay, plus 2.4 times 5. Okay, and this is nice. I can double check my work, see what's all there, and then I see the 2.4 is outside the parentheses on both of these. You can decide however you want to do it. But 2.4 times a is just 2.4a plus, and then 2.4 times 5 would be 12. That's it. That's all we can do. That's an equivalent expression of this using the distributive property. You're distributing the 2.4 to the a and to the 5. Okay, next thing's next. We've got 3 times b. Oh, wait, pause it. I would like you to do this one. Okay, so teacher, please pause it, and then when you get lots of pencils that are done moving, check out and see how they did. Okay, 3 times b. Okay, there, 3 times b. Okay, I'm plus, and then 3 times 6. Boy, these look a lot alike, don't they? But anyway, this is a b, that one's a 6. B plus 6. Okay, it looks beautiful. The 3's are on the outside. Beautiful. Okay, so we get 3b plus, and this 3 times 6 is going to be 18. Gorgeous. Just gorgeous. Okay, now these other ones were all with addition in between them, but you can also do these with subtraction. So let's look at this. This is 3 times m. Well, you know, I'm going to rewrite this. This is 3 times the quantity of m plus a negative 4. Remember, we've done this before. I've talked about how this is really plus and negative. Add the opposite. Okay. So now we can go ahead and look at this another way. 3 times m is 3 times m plus 3 times a negative 4. Okay, maybe it's easier to see that way. So we'll go ahead and clean this up. We get 3m plus a negative 12. And when we simplify things, we like to limit the number of signs to, so we would go and do 3m minus 12. Now you might be thinking like, well, Mrs. Ellsworth, I could see 3, let me clean this up here for a second. I could see plenty easily 3 times m, 3m, and minus, and then 3 times 4 for 12. Yeah, it does work pretty nice this way. But when you start putting negatives on the front, and you have negative inside of here, we need to think of it this way. Let's practice it one more time with the 2/3 here. We get 2/3 times d. Okay, and we'll just go ahead and look at this since we don't have a negative on the front. We can do that. Minus, and then 2/3 times 3. And I'm going to put 3 over 1 because, you know, we got to go ahead and clean it up like that. And, boy, I wish I would have left some more room here. You get 2/3 d. And then I can do some canceling out here, and I get a minus 2. 2/3 times 3 is going to be just 2. So that's the equivalent expression for that one. Okay. Now, let's look at this one. We've got negative 7 times e. Okay, negative 7 times e. Okay, and this is really again plus a negative 4. Okay, so then we've got plus, and then we've got that negative 7 times a negative 4. Pause for a second, just look at that. Okay, so I'll go ahead and clean this up. This is going to be negative 7e. Okay, and then now look at this. Negative 7 times a negative 4 is going to be a positive 28. Positive 28. That's it, right there. So that's kind of hard to see if you are looking at this one originally. It's kind of hard to see that we would have a negative 7e, and then, would you have gotten a positive 28 there? Anyway, so on these ones right here, you have to show these answers right here because those ones are definitely the same equivalent expression of these. So when you've got the variable in there, I will see this in your answer, so that's good. But when you've got numbers up here, I definitely need to see these numbers and how you factored it out like that. Okay, let's do a couple of examples from our homework. Okay, we're going to take 8 times 50 and 8 times 4. And we're running out of time, so you're going to have to continue on with this, okay? See you later.